Now my first question is, this is your question, and it is given that fx is differentiable at x is equal to 0 and this is less than 2, and you have to find out the value of a, as well as you have to find out this, you have to prove this, prove this. So uh, uh, now I am going to solve it. So here it is given that since fx is differentiable, since fx is differentiable at x is equal to 0, so therefore fx is continuous, so it is continuous at x is equal to 0, so it is continuous at x is equal to 0. That means your left hand limit is equal to right hand limit, and this is equal to at x is equal to 0. So I am proceeding from the right hand limit. So your right hand limit x tends to 0 fx, that is equal to limit your h tends to 0, that is f 0 plus h. So this will be limit your h tends to 0 e to the power of a 0 plus h by 2 minus 1 by 0 plus h, that is h, 0 plus h, that is h. Now here you see that we get this is equal to limit your h tends to 0 e to the power of this is a h by 2 minus 1 by h. Now to solve this I am going to use this formula, limit your x tends to 0 e to the power of x minus 1 by x, this is equal to 1. I am going to take the help of this. So here this will be limit h tends to 0 e to the power of ah by 2 minus 1 by ah by 2 into 2 by a. So here this will be this part will be, it becomes to 1, it becomes to 1, so this will be 1 by 2 by a, so this will be a by 2. So this a by 2, your a by 2, this is at x is equal to 0, it is half, so this is half, so your value of a is equal to 1. This is your answer. This is your answer. So let me write here the value of a I have got, that is equal to 1. This is the value of a I have got, this is equal to 1. Now we have to prove that 64b square is equal to 4 minus c square. To do this I am going to take the help of left hand derivative is equal to right hand derivative. So your left hand derivative is equal to right hand derivative. So here you see that your left hand derivative, that is limit your h tends to 0 fx minus h minus fx by minus h. So here this will be less than 0 because we are testing at x is equal to 0. Left hand derivative means less than 0, so this is your function less than 0, so this is your function. So here this will be limit h tends to 0, that means b sine inverse your, this will be, because I am testing at 0, so 0 minus h plus c by 2, and f0, your f0 is half, so this is half, and by your, this is your minus h. So here you see that if I put the value of 0 here, it becomes non-defined. So I am going to take the help of L'Hospital rule. I am going to take the help of L'Hospital's rule. Here I am going to take this help of this. So here this will be differentiation of your, this will be b into 1 by root over 1 minus 1 minus h 1 minus this is 1 minus h plus c by 2 the whole square, and differentiation of because they chain rule, that is minus half, and differentiation of this half is 0, and here this is minus 1. Differentiation of h, that will be minus 1. We are differentiating it with respect to h. So now if this cancels out, now if I put the value of 0 here, so this will be b by 2 and into 1 by root over 1 minus c square by 4. So this comes out to be this much. So this is your left hand derivative. Now let me write here the value of left hand derivative. Left hand derivative is your b by 2 into 1 by root over 1 minus c square by 4. This is your left hand derivative. Now let me move to the right hand derivative. So when I move to the right hand derivative at x is equal to 0, again for same x is equal to 0, your right hand derivative, this will be limit your h tends to 0, f your this will be 0 plus h minus f that is 0 plus so 0 plus h, okay, by f 0 by h. So that means I'm testing at 0 plus h, so this will be right hand greater than 0, so this will be your function. So this will be limit your h tends to 0, so this is equal to e to the power of a 0 plus h by 2 minus 1 by 0 plus h, that is h, minus 0, that is your half, and by h. Now you know that the value of a is 1, so I am going to put the value of a here. So this will be limit h tends to 0, so this will be e to the power of h by 2 minus 1 by h minus half by h. Now I am going to take the LCM here. So this will be limit h tends to 0, so this will be h e to the power of h by 2 2 minus 2 minus h by this is your this will be 2h, so this is your h. So here you see that this becomes what? This becomes limit your h tends to 0, so 2 e to the power of h by 2 minus 2 minus h by 2h square. So now to solve this, I am going to take the expansion of e to the power of x. Your e to the power of x, that is e to the power of x, that is 1 plus x square by 2, and it goes on. This is your e to the power of x expansion. So here this will be equal to limit your h tends to 0 2, and here e to the power of x, that is your x is h by 2, 1 plus h by 2 plus h by 2 the whole square by 2 plus dot dot dot, it will go like this, minus 2 minus h by your 2h square. So now here you see that your limit h tends to 0, that is 2 plus h plus 2h plus h square by 4 plus dot 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 minus 2 minus h by 2h square. So here 2 cancels out, h's cancels out, so this will be equal to limit your h tends to 0, that is h square by 4 plus dot dot and by your h is cancelled, so this is 2h square. So here you see that h square cancels out and your result is 1 by 8. So your right hand derivative result is 1 by 8, and your left hand derivative your result is this. So your right hand derivative result is your 1 by 8. Now since left hand derivative is equal to right hand derivative, because it is differentiable at x is equal to 0, so what I am going to do is that you see here what I am going to do is here, that is your this is left hand derivative. Your left hand value of left hand derivative is b by 2 into 1 by root over 1 minus c square by 4. c square by 4 is equal to 1 by 8. So this will be, if you squaring both side, you're squaring both side, this will be b square by 4 into 1 by, this will be 4 minus c square by 4 and is equal to 1 by 64. So this 4 cancels out. So here you see that 64 b square, this will be equal to 4 minus c square. So this is your proved, we have proved it. So this is, we have proved it. Now my next question is, here you see f double dash this and fx is continuous as well as it is double differentiation, differentiable function, and gx is equal to f dash x. Now you have to find out the value of this. So what happens when you see such type of questions, most of the students, it becomes a confusion for them that we have not given function fx is equal to what it is. So where will I put the value of 10? So nothing is given to you. So here this is an interesting question. So here you see that your f double dash x is equal to minus fx. So here you see that this can be written as d by dx, f dash x is equal to minus fx. This can be written as this. So we know that f dash x is equal to gx, so this will be gx is equal to minus fx. Minus fx. So see, I have got this two relation and one more relation, that is gx is equal to f dash x. So I have got three relations. Now what happens to solve such type of questions? We do not know, we know the value of fx, this is only given in variable. But what is this fx? This, it is not given to you. Only it is given that f5 is equal to 5. You have to find out the value of f10. So how to solve such type of questions? So here one thing is that your fx, you know that fx, and what do we do again? Then we find this f dash x, that is we differentiate it, and to find the critical points we do this is equal to 0. To find the critical points, that means critical points, that means we are finding the value of x, we are finding the value of x. So at the same time if or your f dash x, it comes out some value, then I can assess what the fx may be. So let us find out the derivative of this. This is equal to, because f x by 2 the whole square plus g x by 2 the whole square. So this is f dash x. So this will be 2 f x by 2 chain rule and f dash x by 2 and then half. Let me explain you here this. Here you see d your f x by 2 the whole square into d x by 2 by dx by 2 into dx by 2 by dx. So this is the detailed explanation of this. So 2fx, f dash x and 1 by 2. Similarly here you are going to get 2g x by 2 into g dash x by 2 into 1 by 2. So ultimately you are going to get that f dash x is equal to fx by 2, f dash x by 2, and here you see that you in gx you can write f dash x, so this will be f dash x by 2, and for sorry, this is g dash x. 1 minute. Here your this will be 1 minute. This will be d by dx. This will be gx, because here you see your f dash x, that is gx, and this is equal to minus fx. So this will be your this is your g dash x, that will be minus fx. G dash x, this will be minus fx. G dash x, this will be minus fx. So here you see that your g dash x is minus fx. So here instead of g dash x I can write minus f x by 2. So you see that this and this cancels out, so your f dash x is 0. That means your f dash x is 0. That means fx is a constant function. That means your fx is a constant function. This is a constant. This is a constant. So this is a constant. So if f5 is equal to 5, that means your constant is 5. So that means your f10 is also equal to 5. See the point of interesting point of this question. So by the help of f dash x, because I got 0, that means it is a constant function. So it is a constant function. So f5 is 5. So that means the value of the constant is 5. So f10 will be also 5. So this is how we have to solve such type of questions. Now my next question is this. You have to find out the value of alpha. So here you see this. I just expand this formulas. So 1 plus 2 alpha plus alpha square, 1 plus 4 alpha plus 4 alpha square, 1 plus 6 alpha plus 9 alpha square. Now here again 4 plus 4 alpha plus alpha square. Here this again 4 plus 8 alpha, 2 to the 4 to the 8, plus 4 alpha square, and this is 4, 2 3 the 6, 2 3 the 6, 6 to the 2 means 2ab, that is 4 3 12, plus 12 alpha plus 9 alpha square, and here this will be 9 6 alpha, 2 3 is 6 alpha plus alpha square. This is 9 plus this again equal to 4 is 12 alpha plus 4 alpha square, and this will be 9 plus 2 9 is 18 alpha plus 9 alpha square. So this is the expansion, and this is equal to minus 648 alpha. This is minus 648 alpha. So how to solve this? Here if you see this, one thing you are going, if you see this, let me see the setting here. So here 1 2 1. So here you see 1 into 1 I am taking the help of this matrix multiplication. It is determinant, but I am going to take the help of matrix multiplication. Here you see, take the help of matrix multiplication. So here you see a matrix multiplication, 1 into this, 2 into 1, 1 into plus 1 into 2 plus 1 into 1. You get this. Now again, here you see, for this 1 into 1 and 1 in plus 1 into 4 plus 1 into 4. Now for this it will be 1, so 1 into 6 and 1 into 9, you are getting this. So here similarly, for this will be, here you see, for this 4, I am taking the help of this matrix multiplication. By the help of, I am taking the help of matrix multiplication to set this, taking the help of matrix multiplication. So again you see here, see here, so this now this, this. Similarly, for this will be 4, similarly 1 into 1, then similarly let me take 4, 9. That means 149 here. For this, let me take alpha, 2 alpha, 3 alpha, because 3 alpha, and here alpha square, alpha square, alpha square. See, 1 into this, this and this. So again you see, 1, I am taking the help of matrix multiplication. Just I have set this in such a way, I am taking the help of matrix multiplication. You see this, 1 into this plus this into this plus this into this, it is your this. Again here you see, 1 into this plus this into this plus this into this, you will see this. Again you see, 1 into this, 1 into this plus this into this plus this into this, you get this. See. Similarly here again you see, 4 into this plus 4 into this plus alpha square. Again you see, 4 into 1 plus 8 into alpha, and that 4 alpha square. Similarly here you see, 4, then 4 alpha, 4 into 1 plus 12 alpha plus 9 alpha square. So see, I have break this determinant into two parts. I have just take the help of matrix multiplication, because here it is setting some, we know that it is the setting somewhat like matrix. So I have take the help of matrix multiplication and I have break this this two into this two part. So I take the help of matrix multiplication, and this is equal to minus 648 alpha. So this is equal to minus 648 alpha. You see it clearly. I have take the help of matrix multiplication, and how I did this, I think so it is clear to you. That is, first of all I like this. I take the help of matrix multiplication. That is, first of all I this like this 1, and then here you see 2. That means 1 plus 2 alpha plus, that means here this must be 1 2 1, so 1 into 1 1 2, so this again for the second part it must be 1, then 1 4, 1 into 4, so for this second part here again 1 into 4 again, then this must be also 1 into 4 and this must be also 1 into 4, so this must be 1 here, this also must be 1. So for this again 1 into 1 and 1 into 6 and 1 into 9, so this must be this. So for this second one, this must be for the second, that is it must be similarly for this one. Now 4 into this, this into this, this again for this, and for this second it will be this into this 4. This is 4 into 1, that means this must be 4. 4 into 1 and 4 into 2, that is 4, and then 4, this is 4 into 1, then 4, then this must be 2, so this will be 2 into 2, this will be 4, and then the last will be 1, then only into 1 into 1, that will be 1. So here 4 into 1, 2 into 2, so this. So this is how I arranged this and made this into, that means 9, 3 and last will be 1. So here I have added alpha here and alpha square here, alpha square. So I have break this into two determinants by taking the help of matrix multiplications, So that means the value of this is equal to the product of these two determinants. You can make this to a product of these two determinants. So this, if you expand this, it will come out to be 1, that is 2 alpha cube minus 3 alpha cube minus alpha. So this will be minus alpha, this will be 4 alpha square minus 9 alpha square, and again for this will be 4 9 alpha square, this will be 12 alpha minus 9 to the 18 alpha, that is this into this will be 1 4 9 are 36 minus 24, and then minus 1, this will be 2 9 are 18 minus 6, and at the last this will be 1 8 minus 4, that is equal to minus 648 alpha. So this is minus alpha cube and minus 5, this will be plus 5 alpha cube and 7 8 9, so this will be minus 7 alpha cube, and this will be 36 minus 24, so your 36 minus 24 is 12 minus 6 7 8, so 12 minus 12, and this is plus 4, that is equal to minus 648 alpha. So this will be equal to here 5 6 7, so minus 2 minus 5 6 7 minus 2, so this comes out to be 6. Oh, this is not 7. 7, this is 6, sorry, this is 6. So this is minus 2 alpha cube into 4 is equal to minus 648 alpha. So minus minus cancels out. So your 8 alpha cube is equal to 648 alpha. So your 8 alpha, cube, this is cube, minus 648 alpha is equal to 0. So let me solve this. This will be 8 alpha will be your common. So alpha square minus alpha square 8 is 64. So this will be 81 is equal to 0. So your alpha square is equal to 81. So alpha comes out to be plus minus 9. So alpha is equal to 9 plus minus 9. These two are your answers. Plus 9 and alpha is equal to minus 9. So these two are your answer. So the interesting point of this question is that this determinant and matrix, they are both mixed together. So by seeing this, I took the help of this matrix multiplication, and I made it into two parts. By taking the help of matrix multiplication, I made into two parts, because matrix, the magnitude of the, how to find the magnitude of the matrix, you have to find out the magnitude of the matrix, we take the help of determinant. In order to find out the magnitude of the matrix, we take the help of determinant. So ultimately this is a matrix, its magnitude is given here. So I can divide it into two parts. So I can divide it into two parts. So I took the help of matrix multiplication. So this is the main technique and the theory behind this questions. So this is how we solve such type of questions. Now my next question is this. So we have to check which of the options are correct. So here you see that, this is the limit. Limit x tends to 2 fx gx by f dash x g dash x equal to 1. So to solve this, see what I do when I am helpless. So here that is 2, I do not know anything about this, and here I know the value of f dash 2 and g2. I know only these two value, but I do not know the value of g dash x and fx, because g dash 2 and f double dash 2, it is not equal to 0. So what I do, I take the L hospital rule here. When I take this L hospital rule, so here you see that it is the product rule. So f dash x gx plus g dash x fx by f double dash x g dash x plus f dash x g double dash x equal to 1. Oh, sorry, not 0, this is 2. So here f double dash x and g double dash x f dash. So here this is f dash 2 g2 plus g dash 2 f2 by f double dash 2 g dash 2 plus f dash 2 g double dash 2 equal to 1. So now here you see that f dash 2 is 0, so this is 0. Again g dash 2 we do not know, f dash 2 here it is again 0, so this is also 0, this is also 0. So g dash 2 f2 g dash 2 f2 by again here g dash 2 f double dash 2 is equal to 1. So this cancels out, so f2 by f double dash 2 is equal to 1. So f2 is equal to f double dash 2. So here your f2 minus f double dash 2 is equal to 0. So for at least one x belongs to real number. So for at least one, for 2 I have got this, at least one, so for 2 I have got this. So your this option is correct. So your D option is correct. Now my domain, my codomain, it is f such that r 0 to infinity. Here you see my codomain, it is means its value is greater than, it is positive, that means your fx is greater than 0. This means your f dash is greater than 0. It is positive. So here you see that that means your f dash 2, this is greater than 0, because this sorry f2 your function f2, it is greater than 0. Since your function f2 is greater than 0, so here you see that since f2 is greater than 0, f2 is equal to f double dash, so your f double dash 2 is greater than 0, because your domain is greater than 0, so your f2 is greater than 0, and the f2 is equal to f double dash 2, so f double dash 2 is greater than 0. So greater than 0, that means it is the minimum. So minimum, it is minimum at x is equal to 2. So your first option is correct. So here your two options are correct. So this is how we solve such type of questions. So see, the next question is this one. So I am going to, this is your question. So how to prove this? So here you see that these are some of such type of questions, means you have to use your own presence of mind how to evaluate this. So such type of this much, this so this formula tan inverse this tan inverse your x minus tan inverse y, so plus that is equal to tan inverse x plus y by 1 minus xy. So such type of decision or such type of presence of mind, this you must apply, because tan inverse x, there is no other way to solve this. How can you solve this? Neither you can suppose this, but if you are going to completing the square, but only because there is tan inverse x, so you can't bring this in this type of form, root over say x square minus a square or x square plus a square. You can't transform this into the such type of form, because there is tan inverse x is present here. So to solve such type of questions, what we do, that is we we have to apply some such type of apply some presence of mind, or uh, apply some techniques so that I can solve this. I can this can be that means I can solve this problem. So what I'm going to do this, I'm going to take the help of this formula because it is inverse. I'm going to take the help of this formula. So I'm going to take the help of this formula. See what I'm going to do is 1 minus x plus x divided by 1 minus that is x common here, 1 minus x. So here you see a dx. So here you can see that tan inverse x plus tan inverse y by 1 minus x into y. So this is your x and this is your y. So I can I have I have taken the help of this formula, and now I have transformed this into this form. So when I have transformed this into this form, so it becomes easy for me. What I do that where to solve integration, I always bring the denominator to the numerator. It is if you bring the denominator to the numerator, it becomes very easy to solve you. This is the technique I usually apply while solving integration. So here you'll see your denominator is going to convert into numerator. So this will be equal to 0 to 1 tan inverse 1 minus x plus 0 to 1 tan inverse x dx. So this is a definite integration. So I am going to apply the property, definite integration property, that is the P4 property given in your book, that is 0 to a, your 0 to a fx dx. This will be equal to 0 to a f a minus x dx. I am going to apply this P4 property here to in this question. So when I apply this P4 property, this becomes 0 to 1 tan inverse. So instead of x, this becomes 1 minus x and dx, which I have not written here. 0 to 1, that is 10. So this is tan inverse x dx. So here 1 cancels out and only x remains. There is only x. So 0 to 1, this is tan inverse x dx plus 0 to 1, this is tan inverse x dx, and this is equal to 2. This is 0 to 1 tan inverse x dx. So see, this I have proved here. The value of this is 2 tan inverse x. Now I have to evaluate this. To evaluate this, let us see how to evaluate, how I am going to evaluate this. So here again you see that how to evaluate it. So here this is 0 to 1 tan inverse, that is 1 minus x plus x square dx. Let me change the pen. This is so here we know that cos inverse x plus sorry, not cos, that is tan inverse x plus cot inverse x, this is equal to pi by 2. So here your tan inverse x is equal to pi by 2 minus cot inverse x. So this is equal to 0 to 1, that is pi by 2 minus cot. So this is cot inverse x. So cot this will be equal to cot inverse 1 minus x plus x square dx. So again we know that your cot inverse x, that is equal to tan inverse 1 by x. So here this becomes 0 to 1 your pi by 2 minus 1 by tan inverse, this is 1 minus x plus x square, this is dx. So here you see that this converts to 0 to 1 pi by 2 dx and minus dx, that is tan inverse 1 minus x plus x square. So here now we have already calculated that 1 by tan inverse tan inverse 1 by this is 2 tan inverse x. So here I am going to write a 0 to 1 pi by 2 dx minus that is 2, this is 0 to 1, 0 to 1, this is 2 tan inverse x, this is tan inverse x dx. Now here I am going to apply this ILAT theorem, that is ILAT theorem, integration by parts. So if, let me do it separately. Here this is tan inverse x dx. So ILATE, your inverse, and this is algebra. So this will be equal to inverse tan inverse x integration, this is dx, minus integration, that is differentiation of tan inverse x and integration of dx, then dx. So this will be equal to x tan inverse x minus, this is differentiation 1 by 1 plus x square into x dx. So this is equal to x tan inverse x minus 1 by 2 2x 1 plus x square dx, and this is, you know, this will be log. So this will be equal to x tan inverse x minus 1 by 2 log 1 plus x square and 1 plus x square. So this is the value. So I am going to put the value of this here, and this will be pi by 2 your x 0 to 1, this is 1, so 2, this comes out to be x tan inverse x minus 1 by 2 log 1 plus x square, and this is here. So this comes out to be, this is 0 to 1, so this is equal to pi by 2, and here 2 x tan inverse x minus plus log, this is 1 plus x square, 1 plus x square, and so here this is 0 to 1, and this is also 0 to 1. So now what I am going to do here, that means everything is over. I have to just put the value. I have to just put the value, that is it is pi by 2 minus 2, so 1 tan inverse 1, and this is tan inverse 0 is 0, and now plus log, this will be 1, and log 1 is 0, so here there will be only 2 remains. So this is pi by 2 minus 2 into pi by 4 plus log 2. So this value comes out to be log 2. So this is your answer.